Now that we've finished talking about limits, we can get into differential calculus and rates of change. So a rate is just a comparison between two quantities with different units. The word ratio should come to mind when you think of rate. For example, a constant rate is represented by a straight line. So our data is what we call linear. So that means we have a constant rate, and it's the slope of the line. On the other hand, if we have, and this is when we're taking, if we're taking a real life example, and we're taking data, we have, like, let's say distance relative to time. So time is our independent variable, and distance is our dependent variable, because distance depends on time. And so if you plot those, you would probably just be using the first quadrant, positive time, and then positive distance. And then you plot your points and you get your graph. Now, if it's not a straight line, when you plot your data, you might have something that looks curved, like, let's say this function f, which doesn't mean anything, I just made it up. But if I ask for the average rate of change over an interval, it's basically the slope between the two endpoints of that interval. So we wouldn't say that this function has a constant rate of change, because obviously it gets steep and then it's positive and then it's negative, it's zero at a certain point. But when we talk about the average rate of change, that phrase is synonymous with slope between 2 points. So the two endpoints of our interval we'll use to calculate our average rate of change. So how are we going to calculate this? And instead of using x's and y's, you can see that I've labeled these 2 points. So the first point, right here, would have coordinates a, comma, and then f of a, whatever our function f is. And the second point, right there, would be b, comma, f of b. And so if I want to calculate the average rate of change, I want to calculate the slope between those 2 points. So that's going to be the difference of the y values, so f of b minus f of a, over the difference of the x's, which would be b minus a. Now, could I reverse those? Sure. I could say f of a minus f of b over a minus b. But if I factor out a -1 on top and bottom, I would get this. So here's your average rate of change calculation. And the reason we use this notation, you'll see shortly when we start talking about instantaneous rate of change. All right. So problem sets deal with those two basic ideas, 11a.1 and 11a.2.